Yeah, hello. How's it going? Um, what's up, guys? I am back today. We're gonna be doing a lead code contest. We're gonna be doing it's the bi-weekly contest number 189. 189. Have it registered? I have not registered. Okay, I'll register for it. Okay, so we're doing lead code bi-weekly contest number 189. Um, so Yeah, we're gonna be doing. I got a little bit of like an itch, um, last contest, and I think it'd be cool to do another one. Just see if I still do, eh, or if I can do a little bit better than last time. For now, let me prepare some of my environment. Okay, I wanna. I'm just gonna do this in the background, but I know it's a little bit early in the morning. I know some people like join kind of like in the middle of it. It starts in like 30 minutes, so you have a little bit of a waiting time. What was the previous contest I did? See, LeetCode is not very good for this because I don't, or maybe I just don't know how to use it. But I don't know where to see like your contest rating and the contest you participated in and all that stuff. What is Quest? Yeah, I don't know where to see this. Contest? Past contests. Oh, okay, so I did bi-weekly contest 188. That's the one I did. Which was on August 1st. Oh, okay, so the ones that happen at 10:30 in the morning can happen every 2 weeks. So I can't really do them every week. Because otherwise it's at 10:30 at night and I'm not streaming at 10:30 at night on a Saturday. I'm not doing that. Mm, okay. Make deer bi-weekly 188. And let's uh, make dir make directory. And then we'll move 1.cpp to bi-weekly 1.cpp. Move 2.cpp to there's probably a better way to do this, but move 3.cpp to bi-weekly 3.cpp, and move 4.cpp to bi-weekly 4.cpp. Okay, cool. And then I'm gonna make a directory which is gonna be contest bi-weekly 189. And then it's gonna be 4 problems, so we're gonna just touch. Does touch work? Nope. How do you create files in Windows? I hate Windows PowerShell. Create a file, PowerShell. New item. NI. Okay, so NI new item. And it's gonna be contest bi-weekly 1.cpp. Oh, it already exists because I typed it wrong. This is 189. 2, 3, 4. Okay, we're good. Um, all right. So we're back. We're gonna be doing the contest. What are my plans for this weekend? I don't even know. I know that I want to start doing beach volleyball classes. So I think I'm gonna start next week, and I might be starting maybe like look for some dance classes, but I don't know yet. But I really want to do volleyball again. I feel like I haven't played nearly as much volleyball as I want to, and the summer's almost over. It's not almost over. It's still like 2 months, but it's gonna get colder and colder. And I've been enjoying the weather, but I haven't been able to find places to play a lot. So maybe like the classes will be fun. Um, oh, another problem I was having is I don't know. Okay, let's look at this together. I don't know if there's a way to have this make a sound. Appearance. Um, let's say Restream make a sound when receiving a chat. Okay, it says go to chat, settings, appearance. It says go to notifications. Ah, turn audio alerts. Well, I don't see audio alerts, but I do see text to speech. Okay, what do we want to? Microsoft Richard? Microsoft Lint? How do I know? Don't read links and read emojis is fine. Read nicknames is fine. I just don't know what these sound like. You know what? Let's do Richard. Richard sounds like a distinguished gentleman. Now I want to do a test. Like, do I have to set this up at all? Like, I have the chat there. Okay, let me try. I'm gonna say something like hello on YouTube. That was scary. Okay, we're gonna lower the volume a little bit. Oh, it's here, chat. Let's lower it down to, I think, here, maybe. Actually, I think that just lowers the volume for stream. Okay, we're gonna do another test. Also, let's try the different... I wish it, like, spoke a little bit slower, but it's fine. Enable text to speech. Let's do Microsoft Linda. Don't like that. Okay. You know what? That's the like regular one. I don't mind that one. Okay, that's fine. And then okay, so I'm stuck between Zyra and David. I really didn't like the Canadian ones. I really didn't like Mark. I don't know. Let's do Zyra. Why not? Okay, so now anytime anybody chats, I'm gonna hear a notification in my ears, and that's gonna be maybe a little bit annoying, but we'll see. That's kind of fun. Because yeah, I don't have my second monitor anymore, so I'm not like constantly checking chat. So sometimes people will come in, chat something, and then I won't be able to answer before they leave. So it's good that I have that now. All right, and then we have like 15 minutes. In the meanwhile, I've already set up my environment. Let's do our Lurkana card of the day. Ooh, wait, no, this is not the card I was thinking. Okay, I was gonna say we got Alan Adale. Is this not the card I'm thinking? It is. Okay, I think I talked about this combo like a while ago. Yeah, I talked about this card a while ago, but basically, okay, let's read it. It's an 8-cost inkable, called Donald Duck Coin Collector. It has strength 4 strength, 8 willpower. It's a storyborn hero. And it has 2 effects. One is here, Piggy Piggy. For each item named the nephew's piggy bank you have in play, you pay 2 less to play this character. I don't think this comes into play when you're doing the combo. Maybe it does to like get it out earlier, but like honestly, you still have to get out your monstro. So, and then and actually, I'll do that in a second. But I want to see what the nephew's piggy bank is. And it says when you play this character, your other characters gain draw a card this turn. Exert to draw a card this turn. A quest for 2. It's by artist Rianti Hidayat. It's card 37 out of 204 in English from set 8. It's a super rare. And okay, so I've explained this combo in the past, but basically the effect that is important here is when you play this character, your other characters gain exert to draw a card this turn, and basically you use that with Monstro, where you can discard a card to ready the character, and so with that you can just basically cycle through your deck by drawing, discarding, drawing, discarding, drawing, discarding. You cycle through your whole deck until you only have We Know the Way. So let's look at those cards. So this first Piggy Bank. The Nephew's Piggy Bank. If your character named Donald Duck in play, you pay 1 less to play this item, and then chosen character. I mean, you could play this to get this out earlier. I don't think it's the worst idea. And then, what was the name? We Know the Way. It says this is a song when you shuffle chosen card from your discard into your deck. Reveal the top card of your deck. If it has the same name as the chosen card, you may play the revealed card for free. Otherwise, put it into your hand. Yeah, so you basically like you cycle through your whole deck and you keep one We Know the Way, and you keep at least one We Know the Way on your hand. I think you might want to play just 2 of them. Anyway, you keep one We Know the Way on your hand, and then once that's the last card in your deck, you okay, no. You keep just one in your hand, and then you have at least one in your discard. You sing it using like Monstro. Then you shuffle one of the We Know the Ways to your discard. You reveal it. And then it's gonna be the same card because it's gonna be the only card in your deck. And then you can play it for free, and then just you may play the reveal card for free. Otherwise, put it into your hand. Yeah, and then you just plays itself, and then you just keep cycling basically, and then you just singing songs infinitely. And the Alan Adale, for every song you play, you gain 1 lore, so you can just get to 20 lore in 1 turn if you set up the combo right. Right, I have this on, so I don't have to check anymore. But yeah, so this card, I think the artwork is pretty cool. It's a little bit expensive. The combo is kind of hard to pull off. It's not even in rotation anymore. But it's a cool card that enabled like the first OTK combo. So that was pretty cool. Mm, but yeah, I wouldn't play this anything other than like that combo, or like to get this out as like a final boss character. Eh, I don't really justify like playing the combo is kind of hard to get out. Um, it's cool, but it's not. I would say it's not super competitive. You wait immediately, but you have to like set up the whole thing and not lose to aggro before that. Like you have to get to set 8 and play this and Monstro, which is also like 8 cost. So, not great, but it's a cool card. Okay, 10 minutes to contest start. Um, okay, what else? The rules I think stayed the same. Mm, I think yesterday like things went pretty well for the rack project. Like I got I got my head without too many hiccups, and I still like spent like 30 minutes just researching Lorcana cards and stuff. Um, but like getting ahead in that project, I mean, I think it's cool for me. Oh, and since okay, I have an idea for things I could do to cycle. To cycle for like the cycle of the stream. Since this contest is every 2 weeks, I think, and I think it's kind of like I don't know. Okay, well, it all depends on another thing. But for now, the my idea is since it's every 2 weeks, every second week, what I could do is the schedule like exactly like this week. Do two, one lead code stream, one contest stream, one build stream, and then on the every other week, I do two building in public streams, like the building the rag agent thing, and then one lead code stream. So that way you can sort of balance my itch to do the building stuff stream. But Um, if I start doing this beach volleyball thing, I'll be busy on Saturdays at this time probably, if I go on Saturdays. So we'll see. I'll figure out my schedule. Mm, I'm gonna like go this week, see how it goes. If I like it, then I might just stick around with the classes because I like to play beach and there's only so much time to play it. Like there's like a month and a half. Um, hmm. How much has it been? July, August. It's been 2 months since I started work. I'm still liking it. I'm trying to like I'm trying to like I've been saying this I feel like for a month, but like ease into my hobbies. And so like what I've been doing was like going to like single classes and stuff. What I found with that was that it was really fun, but then you're not in like recurring spaces to meet new people. So you meet people for like one time, and then let's say you hit it off, you maybe see each other again, but like most of the time you don't really see each other again. Okay, in the other cases where you like going to recurring classes, you're seeing the same people, and then there's more probabilities of like making friends and stuff. So that's sort of what I wanted to do, and also because I feel like I haven't played a lot of volleyball, not as much as I would want to. So I've been signing up for stuff. Um, we'll see how it goes. I literally I had to like this week I had to make like a list of to dos for myself because I kept thinking of so much stuff. Um, but I've been getting through most of it. I still have from what I see. Okay, so to this week, if I things go correctly with like the classes, I figured out one, mm, two, three, four of my items, and I have one, two, three, like 5 that are pending but are not so high priority. So I got through like the important ones, I think, and that depending on how much time is taken by my other activities, it's gonna give me some time to concentrate on some of the lower priority items. What is this? Oh. Mm, okay, it starts in 5 minutes. What I was gonna say with these contests was that, I mean, I wish I could do Code Forces, which I guess I can, but they're gonna be virtual contests, and if I'm doing a contest, I want to be doing the real thing. Oh shoot! There's a Huawei ICPC challenge. You get an invitation to the 50th annual ICPC World Finals. Where are they this time? Um, ICPC World Finals, state, like, venue? In Dubai. That'd be cool. You just have to be, like, cracked. What do you have to do? Scheduling algorithm for a collaborative inference system with the rapid advance of LLMs. Services are becoming increasingly integrated into people's daily lives and work. It's called collaborative inference, which is a promising approach to addressing these challenges. This architecture LLM inference is divided between a user's on-premise edge environment. LLM is user on-premises edge environment and the cloud using a U-shaped split. Don't know what that means. The first and last layers of the model run on the edge. The edge would be my computer, for example, while the computationally intensive middle layers run in the cloud. This allows private inputs and outputs to remain on the user side, while cloud resources are used for heavier computation. It requires repeated interaction between the edges and the cloud, both at the prefill and decoding stages. Sequentially can create bubbles, spheres in which computer resources remain idle while waiting for other parts of the system. Concurrent scheduling strategy maximizes order. That is cool. It started yesterday, and there's like a week and a little bit. I wonder, how does it work? I'd have to research into it. Your own computer resources, CPU, memory, disk, such resources can be physical, cloud-based. Each problem in the problem set will be posted as English. Claim of ambiguity or error in the problem set by submitting clarification requests to the judge agrees on ambiguity. Uh-huh. Okay, so you register and there's some problems you have to solve. Huh. Okay, the contest starting soon. I was gonna say it'd be cool to do contest on LeetCode. Sorry, not on LeetCode, on Codeforces. Let's open contest biweekly 89 1.cpp. Yeah. Let's get it. Four questions, 1 hour and a half. We'll see how we do. Okay, learnings, things that I learned from last time, just be patient and talk through the whole approach and don't get like too concentrated. Can I join? Thank you. Elevator request I. Okay. Elevator request I. I'm gonna do it calmly. You're given an integer n denoting the number of floors in a building where the floors are numbered from 0 to n-1. You're also given an integer array requests where request represents the sequence of floor requests. The elevator starts at floor 0. Follow these rules. Moves 1 floor per second. Serves the request in the given order. If the elevator is already on the requested floor, no movement is needed. After serving a request, the elevator immediately starts moving towards the next request. Total time to serve all requests. How many requests are there? 100. Okay. It seems like extremely simple. So basically, let's see the example. So you have five things. What floor do you start? Floor 0. And it takes 1 second to go each floor. Oh, okay, so you just subtract. Okay. Okay, so you keep a count of the current floor. So in curve floor is we're gonna start at floor 0. I said I was gonna be calm. And then for each of the requests, you basically change to that floor, and to your answer, you add the difference from the current floor to the floor you need to go to. So, so not curve flow, curve floor, and so ans is gonna be plus equals the absolute value of curve floor minus request, and then curve floor is going to be equal to request. Any edge cases. You move to floor 2, you move to floor 1, you move to floor 4, you move to floor 3, you add it up. 2, 0, 0. 2, 2, 0. Okay, yeah, pretty simple. And at the end, you need to return ans. Not available during contest. Okay, I'll just submit. Okay, there you go. Pretty simple. Okay, that's better than last time. I got through the first problem like really quickly. Okay, we'll go to problem 2. And then we copy this. Oh. Okay. It says Q2, minimum operations to make a rotated palindrome. You're given a string S consisting of lowercase English letters, so 0 to 25. You can perform the following operations any number of times, including 0, and in any order. You choose index I and replace SI with the next lowercase English letter. And it's circular. Left rotate, move the first character of the string to the end. Return the minimum number of operations to make S a palindrome. Okay. So you have A, B, C, and it takes 2 operations. You have to like basically explore the graph to see what the minimum number is. So you could do like a DP. Okay, let's do a DP. Or I mean, let's think about it first, because I think this graph is kind of big. It's because you could do every single permutation of this. What does moving the first letter to the end do? you move it up always with the next lowercase, so it's always up. Okay. Yeah, I'm thinking DP, which is the brute force approach. I just don't know if it would fit. It's every single permutation. It's 26 to the 2000, which is kind of big. Unless you can do it in some way that's smart and like reduce the number of answers. Okay, let's skip this one for now, and then let's go to the next one just in case. It says you're giving an integer k, an infinite string is formed by concatenating the decimal representations of the positive integers without separators. For every non-negative integer, b, block b contains the positive integers from 10 times b to 10 times b minus plus 9. Okay. If b is even, append the integers in an increasing order. If b is odd, append the integers in a decreasing order. Therefore, the string starts with the integers 1 through 9, followed by 19 through 10. Then 20 to 29, then 39 to 30, and so on. Okay. Kth digit 1 index of this string. 1, 2, 3, 4, 5, 6, 7, 8, 9, 19, 18, 17. Oh, okay, so it starts with 0. The positive int. I guess positive integers count 0 in this case. Because it would be 10 times 0, so 0, or no. Positive integers from 10 to 10 times b to 10 times b plus 9. Yeah, so you start, I guess 0 is even and a positive integer in this case. You do 0 to 0 plus 9, then 1 until 10 because it's odd. And so you can ask for 10 to the 15. Okay, we can there's a sequence here to follow, which is, do you start with 0? No, you don't start with 0, you start with 1. I don't know why it doesn't start with 0. The positive integer, so that's why. Okay. So it goes 1, 2, 3, 9, then 19, 18, 17, until 10, then I guess 20 to 20 to 29, then it would be 29, no, 3. It would be 39 to 30, and then 40 to 49. I think this is how it goes. Right? 1 to 10, 1 to 9, 19 to 10, 20 to 30, 40, 29 to 30, no, 39 to 30, and then 40. Okay, let me just write the segments. It's gonna be 1 to 9, then 19 to 10, then 20 to 29, then 39 to 30, then 40 to 49, then 59 to 50, then 60 to nice. I want to see what happens at 100, because at 100 your number of digits change and you're looking for the ith digit, right? You're not looking for 17, you're looking for 7. So then it would be 79 to 70, 80 to 89, and then 99 to 90. This should be, and now we're at 10, so we do 100. 10 is even, so you do 100 to 109. Okay, so now we're gonna notice the patterns. If you think about it, the first 10 numbers, well, I guess the first 9 numbers, because it goes from 1 to 9. You do it, it's blocks of 9, right? 1, 2, 3, 4, 19, 18, 17, 16, 15, 14, 13, 12, 11, 10. Oh, but this one includes 10, so that messes up the... Okay, that messes up the count a little bit. It should be from 0 to 9, if... Okay, but if we're asked from the numbers from 1 to 9, for the digits from 1 to 9, we return 1 to 9. If we're asked for the digits from 10 to 100, let's say to 99, what do we return? For the digits from 10 to 99, 10 is the 10th digit. Well, I guess 1 is the 10th digit and 0 is the... So we have to separate them in blocks of 2. Right? So you separate them in blocks of 2. And also they're backwards every 2 of them. Okay, let's do the even odd split first. How do we calculate the number? This is just a big formula. The hard part of the problem is just figuring out that formula, but then you can just return it with the formula. For even and odd, so okay, so let's do the rules. If it's between 1 and 9, then just return n. Like just return n. If it's between, let's say, 10 and 19, the 10th and 19th, well, actually not 10 and 19. This would be, how many digits would be? There's 10 digits, 20 numbers. So between 10 and 30, right? 10, 11, 10, 11, that's 2 digits. Maybe 10 and 31. How many digits between 10 and 31? Because it's that plus 1. Or is it 29? There's, okay, so we're just doing this one. So there's 2. Okay, so we're starting at 10. So there's 2. It would be 10, 11. So you basically add it to this. So it's 9 plus 20 would be 29, I think, would be the last digit. The 15th digit is 17. Okay. So between 10 and 29, what's the pattern here? The pattern is we're gonna do them in reverse, right? And there's, I guess, 19 digits, 20 total, counting 10. 10, 11, okay. So you do blocks of 20. And now you separate these blocks of 20 into 10 different blocks, right? 10 to 19, 10, 11, 12, into 10 different blocks. So if they give you do you divide this by 10? Okay, so let's say if we divide this by 10, then we get 0, which is the first one of this sequence. So yeah, you divide this number by 10. Divide by 10, and that's going to be the index of which number of this sequence is. And after you do that, you have to pick if it's the first or second number. So if it's remainder 1, if it's 0, first digit. If it's 1, second digit. Right? So you'll divide it by 10. No, you don't divide it by 10, you divide it by 2. And there should be 10 to 29. And then if you have remainder 1, you get the second digit. If you have remainder 0, you get the first digit. Right? Because everything of it's 2, okay? So there's probably the same rules. And you have to write the sequence is going to be, so you basically you get the box where you're going to. Then you create the sequence based on if it's going upwards or downwards. So you calculate that, which we'll do in a second. And then you use this formula to get you use this to get the position, and you use this to get the position. So when you get to 100, it would be divided by 3. And actually, this is not percentage 1, this is percentage 2, modulo 2. And then you do modulo 3 to find which digit. Okay? Now, let's do, how do we find if it's even or odd? And then how many numbers are there in each sequence? So, let's do now from 30 to, it would be plus 19, so to 49. You do the same. You divide by 2, and then you take modulo 2, and then 0 or 1. And then it would be 50 to 69. So these are the numbers from 20 to 29. Right, so these have to go backwards, these have to go forwards, these have to go backwards. So let me write, this goes backwards, this goes forwards, this goes backwards. And how do we find that? It's every 19 digits. The thing is, you have to generalize this until 10 to the 15. but I feel like we're gonna find the pattern. Backwards, forwards, backwards, and then forwards again. Okay, so and then it's 1 to 9, 10 to. Okay, so for the first one is the first 9 digits. Then this is like the difference between this is not 9 but 8. The difference between this is 19. The difference between this is 19. Okay, let's go to 100. It should be. What should it be? 29 difference because it's 3 digits. Okay, let's say some digit x is when you get to here, 200 to 109. From 100 to 109, how many digits are there? It's 3 times 10, so it's 30. It's 30 digits, so you go from x to x plus 29. So instead of 19, you do 29. And this one, you do 8 because you start from 1 for some reason. They make this problem harder because of that, for no reason whatsoever. X plus 29. And then you divide by 3 and do that. Okay, so and then when you get to 1,000, it's going to be x plus 39 because there's going to be 4 digits. So we generalize that, right? So it's the number of digits is going to be just basically the number of digits times 10 minus 1. Number of digits times 10 minus 1. Okay, how much is the whole block of the numbers from the whole block of the numbers from 10 to 99, which are all the 2-digit numbers? How many numbers are there from 10 to 99? It's basically 99 minus 10. So 89 plus 1, there's 90 numbers. There's 90 numbers, and each have 2 digits, so there's 180 characters. Okay. Characters is going to be equal to number of digits which is 2 times number of numbers, which is 90. Number of digits times number of numbers. So 2 times 90 is 180. 180 numbers. Right? Because there's there's 9 numbers and 180 characters. 100 is 90 numbers for 2 digits. So 180 characters. So basically from here to here, this number, we can find out what it actually is going to be. And this number should be this plus 180 minus 1. Right? So this number is going 69. Like this number should be 190. Does that make any sense? I'm trying to figure out if it's 190 or 189. It's 180. Okay, so we know there's 180 digits between 10 and 99. because there's 99, 99 minus 10 is 89 plus 190. And there's 2 digits for each. There's 180 characters. 10 and 11, 12 and 13. So I think it is 190. Yeah, because if you go 189 minus 10 is 179 plus 1, 180. So then it starts from 190, 2x plus 29, which is 219. Okay. Now we have to figure out x plus 29, and then this, there is how many numbers from 100 to 199? No, actually, from 100 to 999. That would be 900 numbers. Okay, so then characters is always 9, so it's always there. It's 90 characters for 10 digits. Sorry, it's 90 numbers for 10 digits, 900 for 1,000, 9,000 for 10,000, and so on and so forth. And the number of digits is easy to find. Okay, so we separated in the blocks of like the number of digits, right? So there are 8 digits to begin. We can just write that as a base case, I guess. Okay, let's start writing our assumptions. So we'll write the base case where if, let me not write it there, here. Main operations, no, we're gonna go to 3, and then copy this, paste. So if k is from 1 to 9, so if k is less than 10, return k. Then we're just going to count that we start from 10, because that way it's going to make it easier, because there's something that doesn't match here. Now we divide in between this. So from characters, do we subtract 10 just to make it easier? Okay, so we start. Let's subtract 10 from k minus equals 10. And now we're gonna do buckets. So we start at 90. Number num of nums starts at 90, right? And every time we check, are you in between the first 90? If not, just subtract 90 from that and then change it to 900. And then, okay, that makes it easier. There we go. So while k is bigger, I think it's bigger than or equal because the first, let's say bigger than or equal to num of nums, then we do k minus equal num of nums. So now we figured out how many digits we're at. And then let's say int num digits is going to be equal to 2. So then num digits is also going to increase plus 1 by 1 every time. So it's like 90 numbers, 900 numbers, 9,000 numbers, and so on and so forth. So now we've figured out how many digits and how many numbers there are. Right, which is going to help us with this, because this is the number of digits, and these are the buckets. which are basically 19, 29. So it is basically 9 plus 10 times digits, number of digits, minus 1. Ten times that. Or, yeah. So in the case of 2 digits, then it's just 10, then 20, then 30, then 39, 49, 59, and so on and so forth. Okay. So we know our number of digits and our number of numbers. And then also number of numbers has to be multiplied by 10. Okay? Knowing number of digits and number of numbers. Okay. Now we have to figure out this first sequence is always going to be odd, right? Because this one which is 100 is odd because it's 10. So it's going to be odd even, always starting with odd. Okay. So now we have to figure out which number of the sequence we are, and then whether that number, or yeah, we have to figure out which slot we're in, and then whether that slot is even or odd. So to figure out the slot, which one of these slots there is, it is 19. Okay, so int num digits in slot is going to be equal to 9 plus 10 times number of digits minus 1. So that's going to be the numbers in the slot, starting from the thing. And okay, let's see. So there's 19 digits in the slot. So if we're looking for number, I guess we would start this at 0. So from 0 to 19. No, we want there to be 20. So yeah. So from 0 to 20 to see which slot it is. So actually just it's 10 times digits. Right? So from 10 to 30 not including. So that's going to be 0. 30 to, So our slot number is going to be equal to k divided by our num digits in slot. Rounded down. That's going to give us 0, 1, 2, 3. And then our which number it is in the sequence. Which number it is in the sequence. Do we go in? We have to go in the slot already. We can't just do it for everything. Okay, so we know our slot number. So if our slot number is even, then we need to do it backwards. If our slot number is odd, then we need to do it forwards. Okay? and we're gonna write the numbers in that sequence, and then just go look for the ith character. Okay, so, and we sort them. Okay. So we know our slot number, so now let's write the numbers in the sequence in the order that we want. So if our slot number is even, then we do it backwards. Else forwards. Now we build the number sequence. How do we build a number sequence? So let's say we're at 100, right? And we get that we are slot 3. So this would be 110. $119 to 110, and then 120 to 129. It would be 120 to 129. How do we find this out? Well, slot 3, it is actually going to say 2. Number slot is going to say 2. We just start from the number of digits, and then we add 2 times 10. And then we type those 10 digits. So our int L is going to be equal to num digits. This is actually num numbers in slot. Num digits times 10. And then R times 10. Okay, but R then plus. So in this case, it would be 10 or 100 or whatever. Plus 10 times our slot number, right? So it would be 100, and if it's slot 0 plus 0. If it's slot 1, 100 plus 10. If it's slot 2, 100 plus, and then our R is going to be equal to L plus 9. So this is going to be including. These two are not going to be including. So now we got like 120 and 129. Now we build the numbers. Let's just do vector int. I'm going to build our slot. And then for int I equals, or actually, yeah, let's do it this way. For int I equals L, I less than or equal to R, I plus plus, slot dot pushback I. Okay, and now we gotta figure out which number in our slot we are. So we have all the numbers. Now, if it's even, we do it backwards. So sort vector int backwards. Okay. If our slot number equals 0, then we sort slot dot begin, slot dot end, greater int. Okay, so we sorted backwards. Now we find out which number in our slot we're in. How much time do I have? 50 minutes, okay. Okay. When we find out which number in our slot we're in, let's look at the thing. So we have the slot. We have all the numbers. Now depending on K, which K is going to be a number from 0 to our like this number, a number of characters, so to 0 to characters in like this slot. Okay, so how do we find out? Using K, which number we should pick. We should actually reduce K further to just be one of the 10 in the slot. So our int K, or actually K, is going to be equal to one of the 10 numbers in the slot, or one of the however many characters in the slot. There's this many numbers in the slot. Now we have to pick which number it is. This many numbers in the slot. K is gonna be equal to K modulo slot number. I think this should be modular, no? Oh, actually, K modulo num digits in slot. And that's gonna tell me which character in the slot from 0 to 10, or 0 to however many characters there is in one slot. I am. And now that I have this character, I just go in order. I just go in order character by character until I find the number I need. Okay, so we do in splits of 3. I equals 0. I less than K. Is it less than or equal? Maybe it is. Yeah, it's probably less than or equal. I plus equals 3. Or I'm saying 3 because I'm working with 3-digit characters, but this should be num digits. And so we're gonna get the number. So we don't need to go in order though. We can just find out which slot it is between the slots. This is which digit it is. Now we divide them by 3 to find out which number it is. So our desired number is going to be equal to slot of K divided by num digits. That is our desired number. And then we do that modulo 3 to find out, modulo num digits to find out which of the however many numbers that we want. So we convert. Actually, this should be, let's say it's a string to make it easier. And then we do convert int to string C++. To string num. Okay, so we do to string of slot. This is our desired number, and then our desired digit is going to be equal to convert string to int, or chart to int. Is going to be our desired number of K modulo num digits minus 0. And we return our desired digits. I somewhere in my logic might have failed here, but let's test. Num of nums slot. Num of nums in slot. Four, yeah. 7, K equals 15, output 7, 11, 9. Okay, seems to be working. Uh, 10, our output should be 2, our output was 2, and we set 9. Two and expected 1. For a 10th. was it 2? Okay, let's see out desired number, desired digit. $29. When we asked for the 10th number, it went to 29 instead of 19. Okay, let me print the rest of the stuff. Slot number. What else am I printing? The slot number is 0, and our desired number is 29. Well, slot number being 0 is fine. L is num digits times 10. Two digits times 10. It's 100. Number of digits minus 1. This should be bigger. So if it's 2 digits, just multiply by 10. Okay. Okay, so it's slot 0. Let's print L and R. L R 10 to 19. Okay, this one 4 doesn't print anything, obviously. 10 to 19 is slot 0. Its desired number is 17, so we print 7. Is that true? 17, and then the second one we print 7. Okay, this one is, it's the 0th slot, 10 to 19, it's character 19, and we print 9. Okay, let's comment that out. Submit. Minus 48, why? Oh, I should be using long longs. Int replace with long. Let's see if that works. Seems like it. Minus 48. Um, 40 to 49, and then it printed minus 48. Why? This is not that big of a number, so actually, I don't know why I was concerned about like a big, too big. Let's do C out K, yeah. And then that, and then num digits. Okay. K is 8. And then num digits is 3. And here, let's do C out I. Space. And then here we do a C out in line. Boom. Bam. Okay, see. Oh, right. So we do need to convert string to int. It's in our conversion that's wrong. So it's on -0 here. So we have a string. Wait. K. Num digits is not 3. Why is num digits 3 here? Yeah, because it tries to find the third character in that string, and there's no third character. But the desired number is correct. Somehow. It also want to find the second character. Wait, what was it printing before? It was giving me a... Okay, so... Oh, that gives me 2. but it should be. Is it the 8th character in the sequence? 1, 2, 3, 4, 5, 6, 7, 8. No. 1, 2, 3, 4, 5, 6, 7, 8. That's K. So we don't modulo by the number of digits. We divide. Which I don't know why it's 3. Slot of K divided by number of digits. A divided by 3 is 2. What? I'm confused here. How is it giving me 47? Oh, because it's starting from the back, right? It's actually 49, 48, 47. Right? No, it's 40 to 49. Slot number is 2. If it's even, sort it backwards. I'm getting confused the numbers with like the actual thing. So but it's only fitting for this number, which is weird. Okay, we're gonna try to solve at least this one. So this is 2, right? And that's why it gets 47, because it goes 49, 48, 47 for some reason. But it's the number digits doesn't make any sense. The number digits should be 3. So it should be 2, right? So you do 1, 2, 3. Okay. Let me print better. Okay, so we're gonna print 68 gives me 48. Should give me an 8 minus 48. Should give me, wait, expected 8, but it says my number is 47. There's no way. So I'm calculating it wrong. How am I doing the rest right? 15, 7, 8, 11, 9. Num digit starts at 2. If it's not in the first 90. Wait. It's not in the first 90. So wait, we subtract 10 first. So it's not in the first 10. So it's 158. Then it's not in the first 90. Wait, 90 times 2. Well, k is bigger than or equal to number of nums. Times num digits. Then we reduce the number of nums. We reduce it by number of nums times num digits. And then we increase digits by 1, we multiply number of nums by 10. Okay, then number of nums in slot. Four, 4, 15 minus 48. The 15 digit is 7. We need the fifth. 0, 1, 2, 3, 4. Or 1, 2, 3, 4, 5. Okay. We got this. Okay, let's go from up to down. Number of nums to number of digits. Okay, now here, let's, for all of these, let's see out, arcade. And let's check that that's correct. So 5 for 15 reduces the first time and gives me 5. 4 is 4. 11 is 1. 10 is 0. And 168 is 158. It's the 158th character. Now, number of numbers in the slot is 10 times num digits. In the slot. I don't know what num and nums in slot. Our slot number. Oh, okay. I know. And then a slot number is k divided by that. So our slot number here is k divided by 10 times 2 by 20 digits each. So for that, it says it's this one. It should return an 8. So actually I was going with the wrong assumption. It should return an 8. So it says it's this. Does that make sense? 20 divided by 158, or 158 divided by 20, it's 7.9. So it's the seventh slot. 0, 1, 2, 3, 4, 5, 6, 7. That would be 80, right? So 0, 1, 2, 3, 4, 5, 6, 7. That would be 80. So we got the right slot. We got the right numbers. L is going to be equal to the number of digits times 10. So 2 times 10, 20. Or this is 10 to the however many power. So this is actually how to raise a number to a power in C++. Pow, base exponent. Okay, so pow of 10 to num digits plus 10 times slot number 10 to the 2 is 100. Number of digits minus 1. Okay. So it'd be 10 plus 10 times the slot number, and the slot number is 7. So 10 plus 70. That's the beginning, and then that plus 9. We get all the numbers. Okay, let's just go to the we get all the numbers. This is 80 to 89 should go forwards. The num slot is 7, it's odd, so we don't sort it backwards. Our desired number is 89, and our K is 18. K divided by, I think, num digits minus 1. Where's my num digits? 2. Actually, no, K divided by 2 is fine. Desired number is that? 8. Okay. 4. 7. And next should be 9. 9. 1. And 8. Okay, let's submit. I'm almost passing all of them. I have maybe one little thing. I have 17 minutes to figure it out. Okay, 192. Our K is 2 because it is 90 times. So we remove 1, 182. It's the second number, so it should be the second digit from 100. We remove 180, so this is 2. So it should be 0. 10, it is sorting it. But in 100 is forwards. Because 1, right. So it depends, not if my slot number, not this, but if my L divided by 10 percentage 2 equals 0. I think this is what it depends on. My DL is 100 divided by 10 percentage 2 is not equals to 0. And this should give a 0, and then these should keep working for 7, 9. Maybe this should return an 8. There you go. Okay. 5 minutes times, you know what? I don't care. Solve this one. We have 15 minutes. The elevator begins and enter request. A requests are made simultaneously. Each second, all requests fulfilled. The elevator must select one for either up or down. Request is fulfilled. The elevator reaches the requested floor. Start person. 6 floors, starts at 4, request 1 and 5. So you go to 5. Penalty for floor 5 is 1. Oh, so you have to find the best way to visit all of them, basically. Okay, this isn't so hard. I think maybe if I have enough time, I could do it. Let me do this one. Ah, this problem was convoluted. 2. I'm just gonna write the DP, I think. How long is the string? 200? 2000. Checking if it's a palindrome. It's gonna be expensive operation because you need 1,000 for each. And then if I'm doing like a lot of different iterations, every time checking a palindrome. See, I don't understand this left rotate though. Okay, if you left rotate, what is the state of... So if I have A, B, B, A, what is the state of the palindrome after this? Is B, B, A, A. So this matches with this, and this matches with this, and this matches with this. Okay, A, B, C, D, E, F. We have this. Now we'll have B, C, D, E, F, A. So B is matching with A, C is matching with F, D is matching with E. Is there a unique palindrome? Probably not. Like if you have A, B, A, B. Is there a unique palindrome state? I think there is. A, B, A, B, then... No, because you can also change the letters, so there's no unique palindrome state. How do I know if because but every time you change it, and then how do you change? Oh. Okay, I'm thinking multiple things. I just don't know how to do this smartly. Like I can do like just do the changes until I figure out if it's a palindrome or not, but that's very expensive. That's definitely not gonna go in because checking if it's a palindrome takes a half of the string, 1,000, and then I have to do like multiple states. Minimum operations to make a rotated palindrome 1. Somehow the harder seems easier, but I feel like there's a catch of like how do you do the um first how do you count the penalties? I guess counting the penalties isn't so bad. I didn't check the constraints for that one. N to the 9. Oh my god, okay. I understand that the total penalty isn't it the same? So you calculate the total time. Oh, because you don't know the order in which you're visiting the elevator, so technically it is the same. You just add the time like once for everything. If you have if you have a number line, you have boop, 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 and you start like here. How do you know if it's better to like go up and then go down, or go down and then go up? Because the longer you leave elevators, the more penalty you get. So you have to do you go to the closest elevator every time? So you go to this elevator, then you go to this elevator. What is the difference if you go to this elevator, then this elevator, this elevator? Like if there's a case where, okay, if I have my elevator here, and then I'm here, and then I have this, but then I have all these different elevators that are closer together here. I guess this doesn't make sense, but all of these elevators that are closer here. Isn't it better to go do these right away and then come back for this one, because it's only one adding up, than to keep these waiting and adding and adding and adding time every second? Yeah, because these are going to keep adding on the way, but like this is closer technically. I don't think I'm going to be able to do the approach for any of these. Okay, let me try to like discuss the medium at least. Okay, brutal, the brute force. The brute force is, I have a string, blah, 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 right? And then I have two states. I check if it's a palindrome. I'm doing it recursively. If it's a palindrome, I return the time that it took me to get to that palindrome. And then at the end, I do a minimum of all of the paths that I went through. And then on every path, I have two options. I either change the string by like changing each of the characters, so that is 2,000 different things, or I rotate it, which is 2,000 plus 1 options. But you don't have to do 2,000 options, because there are some options that don't get you any closer to what you want. There's some options that don't get you any closer to what you want. If you already have these two matching, why would you change any of them? So you don't have to do those paths. You only need the paths that like get you closer. So I think maybe there's a way to like do all the rotations first. and then you do the changes. But to do the rotations, can you basically match any letter to any other letter? Is this a property of palindromes? Maybe. Okay. So let's say I have A, B, C, D, right? Right now I have match A to D and B to C. Let's rotate it once. I have B, C, D, A. Now I have match B to A. And we'll count these as unique, so I'm just gonna do I'm gonna order them. So A to D and B to C. Now I have A to B and then C to D. Okay, let's rotate it one more time. So C, D, A, B. Now I have A to C and sorry, B to C. B to C and A to D, which is the first at the beginning. And then if I rotate it once more, then it's D, A, B, C, which is A, B, and C, D, so it's the same thing. And then if I rotate it once more, then I get the original one. So, was there any matches I didn't get? I didn't get A to C. And I didn't get B to C. Do I have B to D? No, I didn't get B to D. So there's a pattern here of like which letters you can match based on the rotation that I didn't know it's a property of palindromes. Okay. And what is that property? It has to be 2 letters away? So, okay, let's see what A matched with. A matched with D, and A matched with B. But A never matched with C. B matched with A. And B matched with D, but never with C. Not C, and then this one, not C. C matched with D and C matched with B, but not A. And then D matched with A and D matched with B, but not C. Wait, no, C did match with D. D matched with A and D matched with C, but D matched with C, D matched with A, E matched with C, D matched with A, D never matched with B. So this BD isn't correct. B matched with A and B matched with C, but it didn't match with A. And then this didn't match with A. C matched with D, C matched with B, C didn't match with A. A matched with C, with B. A did match with B. A, C, this should be not D. C didn't match with A, and D didn't match with B. Why is that? They didn't match with the letter that was 2 ahead of them. 2 letters ahead. So they match with 1 and 3. Is that because they're odd? Is the contest over? Yeah. Okay. Well, I for this one, I think I did good. I solved two problems. There's people that solved all of them in 3 minutes, which is it's bullshit. I feel like it has to be AI. There's no way. Mm, yeah, the LLMs will solve all problems. Leave CQB for Pro. 5.6 solve. Fable 5 didn't solve B. Ah. Well, okay, I don't feel that bad. I didn't solve B either, so Sol couldn't solve it, so nice. Um, I wish you could see my contest rating. Fine. Did I get a better rank this time? I got a worse rank. Okay, well, that's fine. Um, okay. So it didn't match with one that was 2 ahead, so with 3, but it matched with 2 and 4. Sorry, it matched with 1 and 3, but not with 2. Okay, let's do one that's 3. A, B, C. A matches with C. Then B, B, C, A. So A matches with C. A matches with B. And then C, A, B. C matches with B. Okay. B. And this odd one, A match with B and C, and B match with C. So everybody match with everybody. Does that generalize if we put 5? A matches with E, B with D. 3, C, D, E, A. A matches with B, C with E. Okay. C, D, E, A, B. B with C, A with D. Then D, E, A, B, C. C with D. B with E. Okay, and then E, A, B, C, D. D with E. A with C. And then the last one is the same. So A match with B, C, D, E. B matched with D, C, C, D, E. C match with D and E, and D match with E. So everybody matches with everybody when it's odd, and then when it's even, it matches with every odd, everything that's odd. Okay, so that does help, but you have to see what matches, like you have to go further investigate this, because in this case, like every letter matches with every letter, but you have to see the patterns of letters that match. So A and E, when B and D matches when A and E, A and B when C and E. So these are the ones that are, well, it's just that it's circular, so you don't know how far they are really. 1 and 2, okay? One and 2. 2. DC 1 and EMB is 2. And ENA 1. END, sorry, 1, and then ANC 2. So if I pick from the original, any two letters, so basically this, always these two have to be 1 away, and these two have to be 2 away. So if I pick any match of like, these are 2 away, 1 away, and then these are 2 away, I'm going to find one that's matches A and B, and then B and D. Is that right? A and B, and then B and D? A and D. And then, well, it can't be the same letter. It has to be two different. So C and E has to be here. A and B and C and E, yeah. Let's pick C and D, and then A and E. No, sorry, E and B. C and D are 1 away. Now D and E, and then A and C. D and E and A and C. Okay. So by rotating it, so okay, then in that case, you can divide your string, only if it's odd. If it's even, we'll take a look in a second. Where you can divide your string in pairs of letters, and then you just do unique pairs of letters, which I think is way less. So unique pairs of letters would be, and you pair letters that are like 1 away, then 2 away, then that are not used. So I'm assuming when it's 7, you're gonna have a group of 1, then a group of 2, then a group of 3, and then the last one is gonna be left, because it's 3, 5, 6, and then plus 1, 7. That math adds up. So you pair letters with each other. So A can be paired with B, and A can be paired with E. A can be paired with C, but like if you pair A with C, then you have to pair D with E. So that reduces your options, like drastically. Instead of having like 1, 2, 3, 4, 5 5 different rotations. I have, so rotations, I would have 5. Now if I do pairs of letters, because I think these repeat. No, these don't repeat. If I do pairs of letters, but it's the same amount because the pairs of letters represent the thing. But I can find them more smartly. But yeah, the problem is like it's more like a LeetCode hard. Okay, let's do some like short up solving. Actually, I don't know if I have to go. Okay, let me just grab the problem description, and I'm gonna ask ChatGPT to create the variable named Dorivix Alu. Remove that. See, it's so easy to cheat in this. Because you just have to find, like, I know they're putting that because I saw it the other day. So you can't literally just copy and paste it, but if you copy it, you find that keyword and then you do it. Then yeah. Could you explain how to solve this problem to me? The rotations don't actually change the relative order of the characters. They only change where we choose to cut the string. They're all the same circular string, so instead of thinking I can rotate the string many times, I can choose any position on the circle to be the beginning of my string. Yeah, which is I think what I was getting to, kind of. Yeah, so in that case, you're not actually rotating it. You're like, if I pick this to be the beginning of my string, then I know I'm gonna end up matching C and A, I think. No, C and B. C and B are gonna end up matching. They're 1, 2, 3, 4 away, and then D and A are gonna end up matching. So you go over like each of these rotations, which is equal to the number of letters, that's 2000. And then for each of them, you calculate the minimum, cost. So for 2000 of them, you calculate the minimum of like turning it into a palindrome, which is like way easier to do because just 2000 times 2000 is 10 squared. It's y minus x plus 26. Yeah, you don't need to simulate it. There are n meaningful rotations. For rotation, how many rotations does it take to get there? How many increments does it take to turn into a palindrome? For rotation arc, rotation is simply arc because rotating more than ever n times is never useful. Yeah, that's obvious. Okay, it wasn't as hard as I thought. You just had to. The key part there was to remember that if you rotate a palindrome, you're just picking a different point to begin it. And for each of them, you just calculate for each rotation how much does it cost to calculate to make it into a palindrome. Okay. I maybe could have figured that out. Kind of wanna. You know what? I don't think I'm making it to this place today. I'm making plans for today, but I don't think I'm making it to this place today. I can save it for another day, and I can go to another restaurant, and I can try to code it up. Okay, let's try that. I mean, okay, this contest went better than the last one because I actually solved two, whereas in the last one I solved one and I had the answers for two more or less. And this one I had the answers for two, but I didn't really have the answers for the rest, so it's kind of like a trade-off. But I could have solved this. I just have to start thinking about the patterns and simplifying the problem. So I always go like, oh, brute force, brute force, brute force, and then you have to like think about the patterns instead of just trying to think brute force. Okay. So just do for every rotation. Okay, so we're gonna calculate the cost of turning into a palindrome. Okay, so cost of turning palindrome. String S. What is that cost? It doesn't matter if you turn this letter into this one or this one into this one. It's the same cost, should be. So you just have to calculate the difference. You can do it basically both ways. You do it from this to the right and from this to the left. But there is a trick that I saw ChatGPT do that we're gonna learn today. This. Can you explain this? Remember that the increments from x to y would be, why do we plus 26 and modulo 26? Because the alphabet wraps around, so going from y to b takes 3 increments. If we just did, it's obviously not what we want. Yeah, I mean, yeah, sure. Why do we add why do we add 26 to the result? Programming in C++, not Python. Yeah, I know that it. Yeah, but like, give me an explanation for it. When do we have 26? Yeah, 26 doesn't change the final answer. If y comes before x, so we're turning the number positive basically. We turn the difference into positive, so modulo works. Because modulo works both backwards and forwards in Python, and this one you have to turn it positive for it to work properly. Okay. So int L equals 0. Actually, let me do that. And then R equals S dot length. Then we're going to calculate a cost. And then while L is less than R, our cost is going to be plus equals L minus R. I'm going to write it like this so it makes more sense for me. I know it doesn't actually change anything. And then plus 26 modulo 26. And then L plus plus, R minus minus, and return cost. So that should return the cost of turning into a palindrome. Then we actually do the rotations. So for int, how do we do rotations? I less than s, I plus plus. How do we rotate the string? We take the first character and put it to the last. Can you add strings like that? How do you rotate a string in C++? Is that substring one? Yes, that's what I was gonna do. Okay, it's substring. Okay, so int min cost is gonna be equal to 0. Actually, it's gonna be to max int. And then here, I equals 0 this. So min cost is gonna be equal to min cost and cost of turning palindrome of, we have to keep the currently rotated string of s plus I, and then we rotate the string, so s is going to be equal to s dot substring 1 plus s0. So calculate the min cost, rotate, calculate the min cost, rotate, and then add I to the cost, and then return min cost, and that costs way less. I think this is in max, not max int. I need 48. I might have done the formula for this thing wrong. Oh, we do the bigger minus the smaller, so we convert the characters to numbers. Oh, S, L, S, R. Actually, this is char int a equals SL minus 0 minus a SR B equals SR minus a. B minus A. For the cost of, for the, I'm just gonna say B minus A plus 26. Modulo 26 does the order of B and A matter. The minimum, I guess, the minimum of this and A minus B plus 26 modulo 26. But I was getting negative numbers, wasn't it? Yeah, I was getting negative numbers, which is not good. I wonder which advanced models. Anyway, let's go back. I know. Okay. So it was that apparently. Okay. Okay. Okay, well, fair enough. This was easier. This one was easier than I thought. It was just a matter of like thinking about the problem like differently, like about the rotations, like how many unique rotations there are, and then the cost of turning a like you just have to organize the problem differently. Because like rotating a letter, I did get to a key at some point because I think I mentioned, okay, you probably do the rotations first and then calculate the palindromes. I just didn't think like, oh, for every unique rotation, calculate the number of change for algorithm. This problem was easy. I just probably have to see that next time. But it was not too bad. And then before I go, I'm not gonna actually like solve it, but let me just grab these instructions and then ask it to just explain the problem to me. Explain the solution to this problem. Where's the variable? Where's the thing? Ah, right there, I saw it. Hideous, the order in which you visited the requested floors matters because every request accumulates penalty until you reach any. We tried all the permutations of the request, which is impossible. Since the other ones are looking to 1D line, there's always an optimal solution once you start serving requests on one side of the current interval. You don't need to jump back and forth arbitrarily. We can use interval DP. So you don't wanna like go down and then go up, no go up and then not go up, go down, go up, go down. Why not? Why not? Arbitrarily. Okay, this explains it like way too much in detail. This is the implementation? Damn. Um, yeah. Okay, so yeah, so basically you, let's go back to the number line. You put an interval, it's an interval DP. So you have, let's say, all these floors, that's which I identified the number line, and then you start here. Then you serve. Wait, how do you initialize the thing? So once we reach AI, the request is fulfilled. Okay, let me see the main operation. You start a request, push it back, sort it. Nice. You like initialize it, and you expand the intervals. How do you find the closest? Like, how do you know where to start? R equals... First request. And then if you get there in less time. Okay, I should review this at a later date, but I think the basic idea is somewhere where like you start here, and then you have an interval of which floors you've visited, like which of like the indexes you visited. So if, let's say you've only visited here, then it would like you can number them. Let's say this is 0, 1, 2, 3, 4, 5. You start visiting here, you start at 2, 2. Then you can decide to either visit 3, 2, 2, 3, or 1, 2. And then you can expand basically left and right, and then you calculate the cost of expanding to each of them. And for each step, the cost you add is basically the number of the difference between the floors times the number of requests you have pending. And then you add up all those amounts and calculate the minimum. It's not too hard, but like it's just for these contests I've always found that like you have to solve the first 3 like really fast so you have some time to actually spend on this. Because this you can't just like solve it like that. But in terms of points, it's worth it to solve the mediums and then maybe leave the hard. Like the hard is only 1 more than the medium, so maybe try solving easy, medium, medium, and then if you have time, you do the hard. I don't think it's strategic to like go solve the hard at first, because it only gives you 1 point more than the medium, so you should get like the easy points first. Anyway, I'm gonna cut it off here. Thank you guys for joining, and I'll see you guys next week. Have a good